Alrighty, and the last little bit of functions we're going to look at for today is looking at even and odd functions. So even functions are functions that are going to be symmetrical about the y-axis, or in other words, they're going to have a line of symmetry about the y-axis. So this is seen in things like semicircles and parabolas, in that they are exactly symmetrical on either side of your y-axis. So this can also be true for parabolas that you move around. So they're not always going to be symmetrical about the y-axis, but if you move your parabola to the left or to the right, it's just going to be symmetrical about the middle point at the vertex. Okay, and so the reason that we can prove this, or how we prove this, is if you can prove that f of x is equal to f of negative x, you're going to have an even function. Okay, so the easiest way to think about this is thinking about it in terms of y equals x squared. So our normal fx is equal to x squared, and then if we have f of negative x, we're going to have negative x all squared, and we know that if we do a negative squared, we just end up with it's positive, so it's also going to be equal to x squared. Okay, then their opposite is the odd function, and so odd functions are functions that have a point of symmetry about the origin. So essentially what that means is if your graph is rotated 180 degrees about the origin, it's going to give the original graph as well. So this is seen in cubics and hyperbolas. And so essentially what that means is if we rotate this graph 180 degrees around, if I line it up properly, we're going to have the exact same graph. Okay, let's rotate it 180 degrees, exact same graph. Okay, 180 degrees, the exact same graph. Okay, so essentially that's what we mean when we're looking at odd functions. Okay, so you can prove something is an odd function if f of x is equal to negative f of negative x. Okay, so essentially if we look at this graph here, we have y equals x cubed as our fx. And then if we had negative f of negative x, you'd have negative of the negative x cubed, which you'd end up with negative times the negative, which would get you back to just x cubed. Okay, so we've got some example questions to look over. So I'll give you guys maybe a minute or two to have a go at these questions. To prove that some of these are even, odd, or neither. So it is possible that your graph is not going to be even and it's not going to be odd. So yeah, I'll let you guys have a go at these. I'll give you about 2 minutes. Type your answers in the chat if you're watching it live. If you want more time, pause it. If you don't want any time, skip ahead to the solutions. Okay, so we'll go through the solutions for part A first. So prove that fx equals x squared minus 4 is an even function. So we know that something is going to be an even function if f of x equals f of negative x. So we need to find what is f of negative x, and we do that by substituting in negative x wherever there was an x in our original equation. So then here we're going to end up with negative x all squared minus 4. Once we do this square, we know that if we square a negative, we just end up with the positive. So we're going to get x squared minus 4, which is equal to our original fx. So therefore we can say f of x is an even function. And it's as simple as that to prove that something is even. To prove that something is an odd function, if we've got fx equals negative f of negative x. Okay, so for our original function here, x cubed for part B, if we want to find negative f of negative x, we want to do negative of negative x cubed, which we then end up with two negatives that when we multiply them together will cancel each other out to get just x cubed, which is equal to f of x. So therefore, our fx equals x cubed is going to be an odd function because fx equals negative f of negative x. Okay, and that's all we have to do for that one. So then for part C, prove that fx equals 3x plus 5 is not even nor odd. We first need to disprove that it's not even. Okay, so whenever you get a question that says prove this is not even and prove it's not odd, separate it into two sections. First prove it's not even, then prove it's not odd. Okay, so for something to be an even function, f of x has to be equal to f of negative x. So in this case, f of negative x, if we substitute that in, we'll get 3 negative x plus 5, which leaves us with negative 3x plus 5, and that does not equal f of x. So therefore, we can say that our fx is not an even function. Then for proving it's not an odd function, an odd function occurs if f of x equals negative f negative x. So in this case, to find negative f of negative x, first substitute in negative x to where there's x, and then we need to make all of that entire function negative. So then we end up with, when we multiply this out, negative 3x plus 5, all of that is negative. So then we multiply that negative out, you'll get 3x minus 5, which does not equal our f of x. So therefore, fx is not an odd function, and we can therefore say that we do not have an even nor an odd function when we are looking at 3x plus 5. Okay, and that's all you need to do with functions in proving that they're even and odd. It can be a little bit tricky to get your head around the f of x and the f of negative x and the negative f of negative x. So I just recommend doing lots of practice with it, but that's the only two rules that you need to know to have to prove whether something is even or odd. Alrighty, so that brings us to the end of our overview of functions today.